Right, so you want to get the data from the Trisonica anemometer onto your device and using a Linux device as a data logger. So what's happening here is if you give the device power, it pumps out data constantly. And you can capture this data with this program on GitHub. What you need for this is you need to download all of these files over here first. Then also download and install the required packages. Afterwards, you can go to your terminal, navigate to the directory with all the files you downloaded. Then you start the actual Python file. 99% of the times it's this one, Python 3 data logger. And then you get to the window. What this is pretty much just the data is flowing from the Trisonica through the adapter, which is like Trisonica data cables to USB-C to the main device. And this is what the device reads in the terminal, the raw data from the Trisonica, and the Python code transforms this into this terminal overlay and interface, whatever you want to call it. So top left, you can see, actually at the top you can see like frequency of the data flowing in. The memory is the current CSV file, so the data that's saved, how long it's running, and what the CSV file is named. The CSV file is pretty much just when you start this program from the terminal, it records data as a block. So it's currently recording data and saving as a CSV file. So as long as the Trisonica is running, it's pumping out data and the program is, saving it pretty much. So reading and saving it. Okay, what's going on here? Top right, you can see explanations to the parameters used on the left side. This is pretty much what's going on in the right at this time in the moment, recorded in 10 Hertz. So we got things like wind speed, temperature, X, Y, wind speed, humidity, temperature, etc. For some reason, with my Trisonica, the true heading and the magnetic heading here don't really work that well, but that should also theoretically work. But that's an issue of the device. By the way, you can calibrate the device also with a terminal. You should probably do that beforehand. And yeah, right. So bottom left is just the current, like the wind speed in the last couple of seconds or minutes at the last 1000 readings. So pretty much just the last 1000 seconds. And it tells you what's going on with the wind speed roughly. So this really doesn't make any sense right now because we're indoors and the thing is laying on the ground. But yeah, this is the rough reading. Data quality, really important. So we have three main sources of data issues. First, these tiny wires here are connected to the main board via clamps, and these wires tend to break very easily. That's why I secured everything in place. And you have to be very careful with this. Also, I made these wires extra loose so they, don't break easily. If they break and the data is corrupt, like it will show things like a -100 temperature or -100 wind speed at some point. And at this point, it will recognize it and show the data quality as bad and how many errors and what percentage of errors we have. Another error source that's important is we have a Linux Zorin device here, and I don't know if it's just an issue of this device, but if you plug in even just a power cord to charge the device, you can see here the data already gets corrupted a little bit. So this easy solution is just to only connect the Trisonica to the device. And the third source of errors is that this is a ultrasonic anemometer, and it sends out and reads ultrasonic waves extremely fast. And if you normally place it, freely in the wind where you want to measure it, then it's no problem. But if you place it on the ground, on a table, for example, carefully, then the ultrasonic waves interact with the table, and this causes the data to, in some cases, become corrupt. Not right now, but bad readings tend to happen when this happens. So these three things happened. Yeah, right. So what's happening right now, as you can see, we're measuring the data that's been flowing for a while now. We measure it for 4 minutes, a little bit more. And the CSV file is in the folder you downloaded, in this output file over here. If it's not there with the other folders you downloaded, then just with the other files you downloaded, then just create it, and the program will, for every measurement, which is, if you just close this with Control-C, then that's pretty much one measurement, even though the device is still running, of course. And this counts as one measurement and creates two files, Trisonica data files and Trisonica stats files. The data files contain the actual files you want to use, like wind data, overtime, temperature, etc., on the device's time. And the stats is pretty much what's happened. For example, if there were how many error readings there were on this particular measurement. And that's it. If you want to do another measurement, you just repeat the process and it starts another measurement. Right. And if you want to stop the Trisonica from measuring, you just plug in this, you just interact with this lever over here and unplug it. Normally, if it's active, it will buzz. You can hear it very lightly, not now, but in real life. And that's how you know it's measuring. So yeah.